let's start firstly talking about maybe the lecture plan of spacecraft dynamics control. Make sure you're registered to EAS 4813. It's elective, so I presume that you have already done your space mechanics, your satellite technology, and launch technology as well. So I think it will be much easier to follow this lecture. I presume there is also some prerequisites that you need to comply before you can register. Okay, since you have been exposed to satellite technology, you have been exposed to space mechanics, this is going to actually be an extension to those two subjects actually. Looking into specifically on spacecraft dynamics control, which means that it is slightly on looking how basically we can ensure a rigid body that is flying in Earth-oriented mission can comply and can serve the mission successfully, and to keep that spacecraft flying. This spacecraft can be space shuttle, can be even a satellite, as simple as that. But most of the exercises that you will see here in the subject throughout will be satellite as a good example. 14 weeks all in the plan for this lecture. More importantly, I think since this is an elective subject, there is a bit of revision that I may want to do. Maybe I will take about an hour or 1.5 hours to do a revision on space mechanics, just a general overview, so that assuming that there are some other, well, I think students are interested to see in this class, they know what you guys are talking. That's one thing. Second thing is that it will be a quick revision, and it will be a very good comparison. What is space mechanics subject is covering, and where we are standing in terms of spacecraft dynamics control, so that we can link them together. They are close, they are similar, but they are absolutely not the same. But the knowledge of both is very important, because you need to operate the spacecraft in its orbit. So when you look at the orbit, then you need to define the orbit. Then you fall back to the space mechanics. Then when you want to fly in the orbit, then you have to actually get back to the spacecraft dynamics control. So this is a very, very important, I would say, relation that we must establish, and must understand very, very clearly what kind of motion that we are going to deal with this subject, or deal with this subject. We will start off with the attitude representation, how we can represent attitude. To simply define what is attitude. For those who have done flight dynamics, I'm pretty sure it will be very, very, I would say, useful to help you to understand even better what is basically satellite attitude or even spacecraft attitude, because it's the same. It's the same, but not our conventions are different. Our flight path is different, but the definitions, or rather the actual quantity is similar. We will define that clearly, and I would like to take maybe the opportunity, while defining the attitude representation, I will take the opportunity to introduce a bit on the space mechanics, just to to quickly to revise some important items. Then the most important thing is that to establish the rigid body dynamics. Now, in satellite technology, we have seen all those subsystems, and we have established all those subsystems, which is very, very important to ensure successful flight in space. But we didn't talk much about the dynamics of the spacecraft itself, or the dynamics of the satellite itself. Now here, that's where we need to actually start looking into the dynamics of the rigid body in space. So we have to establish that. Once that is established, then we can work with its kinematics. Now, as all of us know, kinematics basically involves when the motion, when things involve motion, then we talk about kinematics. When you have a static condition, then you just talk about the transformation. Like transformation you have done in your space mechanics, all those transformation, coordinate transformation, etc., you have done in space mechanics. Here we don't talk much about transformation. There will be very, very almost zero transformation, but there will be a kinematics, full of kinematics because it's motion. There will be a very precise projection that I will explain when time comes. We want to establish equation of motion. So three components. Space is important, transformation is important, you have learned in space mechanics, and here you are going to actually do kinematics, and then later a bit on projection. It's a very simple one to say. After that, when the dynamics is, when rigid body dynamics is established, we know that how this rigid body is going to stay and react in the space. If the condition is ideal, whatever that we have planned, obviously you will respect that and it will stay just like what we have calculated. But unfortunately, it is not. As we have also seen in the space mechanics, there is a lot of orbit perturbations. If your ideal orbit can be disturbed by environment, why can't your spacecraft or satellite can be disturbed? Definitely it will be disturbed. Therefore, the same disturbance are acting on the orbit differently. The same disturbance are acting on the spacecraft differently. But the fact remains that they are influencing, and that needs to be addressed carefully. Okay? Otherwise, we would not navigate, or rather, we would not fly in the ideal orbit. So, environmental effects that we need to know what are the important ones, and we need to quantify it. We have to calculate that. If you cannot calculate that, then you don't end up actually rejecting it. Remember all the perturbations that you calculated in orbital mechanics, all that you have quantified, and you know how to reject those kind of perturbations. So here, you will know how to calculate and basically how to reject them, so that you will be in an ideal trajectory. Then comes our attitude control method. Now, I'm not going to expose you a lot on control systems. It is going to be a short review of control system, and then straight embark on the application. The application is a spacecraft. As a spacecraft, then we want to apply control system to it. But I expect that all of you, if you can remember, is good. But if you don't, please revise your control system, because a lot of I think components will be reused in our discussion, which I may not want to start all over again. So it is important to revise control system, have that all in mind. We will address all these active control methods. So if you can see, this is quite a lengthy week, basically almost about a month we are going to dwell, or more than 2 months, a month plus. We will dwell on active control system, because there are various types of control that you have. There are various control systems actually you have in the satellite. So we want to quantify it, and then see how we can design it. We want to design not a complex one, we want to design a very simple one, so that you know how basically to control a satellite or a spacecraft in its orbit. How to control this. A simple design. Okay, this is important for us to understand. And then followed by basically orbit control method. Now, I've also mentioned to you, we have done that orbit perturbations, and we have identified the quantity which is going to disturb the orbit, but we haven't discussed in space mechanics the way that we are going to do the orbit control. No, we didn't do that. In this subject, I have added that component, just a topic, just to tell you to complete the whole process. After knowing that, you may know how basically I'm going to do orbit control. Based on the requirement of space mechanics, I need to do orbit control. Okay? Orbit control comes in because of the space mechanics requirement, because they are not staying in that ideal Keplerian orbit. It's disturbed. So you need to actually bring back the ideal Keplerian orbit. So what we do? Well, there's a lot of techniques. So we will be exposed to that, and how we can do that. That is important. Then comes attitude determination. Now, if you have studied control system, I'll show afterwards in the introduction. Control system, when you have a control system, obviously you will have the controller, That's why you've been exposed to all those control systems that we have. You have the controller type, then you have plant. Then in order basically to control the plant, it can be anything. It can be car, it can be spacecraft, it can be aircraft. You need to also measure. That's where attitude determination comes in. So in space there are methods of attitude determination. So we will actually look at the methods of attitude, the principle of it. Now, I must tell you that attitude determination itself can be one whole subject matter. Just like spacecraft dynamics and control. But if you look at attitude determination, the whole subject, there will be a small portion they will teach you how to control a spacecraft. So likewise here, we have spacecraft control, dynamics control. So we will teach you also a portion how you can measure the attitude. That is important. Okay. Now let's go to the rule of the game. Attendance is important as you have known in your space mechanics and also your rocket launch vehicle system, rocket system. Attendance is important, and although I think most of the time the lectures are going to be virtual, but nevertheless we can monitor the attendance, your appearance in the slots of your classes. Your attendance can be monitored online. So we are going to pick your attendance, and then I'm going to mark your attendance. So make sure that you come to the virtual class without missing. That's 5%. Is a lot. Okay. Thereafter, the exercises 50%. We may want to do that group exercises. Depending on how many of you, I think it's going to be since elective, it may be a smaller group. We will actually look at the group and then we will start actually the grouping. Then evaluation, further evaluation, we test on test, and project test could be an open book test, it could be a take home test. Let's see how things develop, and there will be a project paper for each one of you. Let us see whether how we can actually do this. The implementation we can actually start establishing when we are progressing. That would be 20%. So that all in all will give you 60%, and inevitably your final exam will be 40%. And there are chances of we are doing it face to face. If it's not possible, then we can still do it online. That is also not a bad option, I would say. We have done this before, and we will be a bit more open-ended kind of ratings. So that is what you can expect for this 14 weeks. And books, I think there is a certain amount of books available. You can actually look up for all these books, but I think again, just like I've mentioned to you, that if you keep to my lecture notes, all the 14 weeks there will be a proper lecture notes. You keep to the lecture notes, and then you do your exercises, you do your assignments, and your project paper. I think you will be in a very good shape, basically. The problem starts is when you start missing the classes and you don't respond to the assignments or exercises. Otherwise, everything what is given in the class, what is discussed in the class, that is important and will appear in your evaluation. Now, more importantly is that although I say that all my notes are complete, but there are things that we are going to discuss in the class which is not available in the notes. There is going to be a general knowledge, and that will be benefited for those who actually attended the classes. So you need to attend both, because information is not only from the notes but also in our discussion, in our presentations, etc. I think that we are probably ready to start our first chapter, and then let's see how this whole semester is going to come. Thank you.